Hello everybody, welcome to Guidance Education channel. We will see the topic that is discussed in this video. We are continuing class 11 physics, thermodynamics. The topic discussed is coefficient of performance of refrigerator and heat pump. Derivation of the formula. This is a very important topic. So watch the video completely without skipping, and if you think the video is useful, do like the video, share the video with your friends who may also be benefited, and also leave your feedbacks as comments in the comment box below. If you have not yet subscribed my channel, do subscribe it now and support me. Thank you very much. Come, let us see the topic. Now let us discuss the coefficient of performance of refrigerators and heat pumps represented as COP. By definition, coefficient of performance beta is a ratio of the cooling or heating effect provided by a cooling or heating unit to the energy consumed by the system. Example of cooling unit is the refrigerator or air conditioner. An example for the heating unit is heat pump. In the previous video, we have already discussed the block diagram for refrigerator, which is also applicable for the heat pump. If you have not watched that video, please click the I button in order to watch that. The symbol for coefficient of performance is beta. From the definition, for the refrigerator, beta is equal to desired output upon required input, which is equal to cooling effect by work input equal to Q2 by W. For heat pumps, instead of cooling effect, we consider heating effect. That's all. That is, a certain amount of work has to be done in order to get the desired output. Cooling effect or the heating effect is the amount of heat absorbed from the sink equal to Q2 in the case of the refrigerator and the heat pump. So beta can be represented as Q2 by W. Remember, Q2 is smaller than Q1. Q1 is the heat that is expelled from the system to the hot source after a certain amount of work is done on the system. When work is done on the system, you know its heat increases. Work done is equal to Q2 minus Q1. Q1 being bigger, the value will be negative. So work done is negative. We want work positive, so we write it as Q1 minus Q2. In order to remove this negative sign, we have just inverted these quantities because we need it when we derive the expression for coefficient of performance. We have already stated above that beta is equal to Q2 by W. W is positive there. So substituting for work done, that is work input, beta is equal to Q2 upon Q1 minus Q2, dividing the numerator and the denominator by Q1, we will get the expression beta is equal to Q2 divided by Q1, the whole divided by Q1 divided by Q1 minus Q2 divided by Q1. This minus. This Q1 by Q1 will be equal to 1. So this becomes 1 minus Q2 by Q1. So this is equal to Q2 by Q1 divided by 1 minus Q2 by Q1. In ideal condition, that is when no heat is wasted or lost, just as what happens in the case of Carnot engine. We have not discussed that. We will be discussing that later. Q2 will be equal to T2, that is the temperature of the sink, that is the space from where heat is absorbed. And Q1 will be equal to T1, that is the amount of heat released will be equal to the temperature of the external environment, which we call the source. Okay. So Q2 by Q1 can be taken as T2 by T1. So substituting, coefficient of performance beta is equal to, instead of Q2 by Q1, we write T2 by T1 divided by 1 minus Q2 by Q1 becomes 1 minus T2 by T1. You have an expression for beta here, Q2 by Q1 minus Q2. That will become beta is equal to T2 by T1 minus T2. Now we will see how efficiency eta is related to coefficient of performance of refrigerator beta. But before that, Let us see the different forms in which coefficient of performance beta can be represented or calculated. This is one expression. Beta is equal to Q2 by Q1 minus Q2. If Q1 and Q2 are provided, then this formula can be used easily. If T1 and T2 are given, then beta is equal to T2 by T1 minus T2. This is under ideal conditions. Then we have the formula beta is equal to T2 by T1, the whole divided by 1 minus T2 by T1, which is equivalent to Q2 upon Q1, the whole divided by 1 minus Q2 by Q1. You also have the formula beta is equal to Q2 by W. These formulae help us to derive the relation between eta and beta. I have already mentioned this formula, T2 by T1 minus T2. We know that efficiency eta is equal to 1 minus Q2 by Q1. We have already derived that in the previous video. Recall what is efficiency by definition. It is input Q1 upon work done. Please compare this with the equation for beta, which is equal to Q2 upon W. Substituting for Q2 and Q1, it can be written as eta is equal to 1 minus T2 by T1. From this, we can get the expression. We will just shift this 1, which is on the right hand side, to the left hand side. We will get 1 minus eta is equal to T2 upon T1. I hope you understand this. Eta minus 1 is equal to minus T2 by T1. We want to remove this minus. So multiply the whole equation by a negative. Negative eta plus 1 is equal to T2 upon T1. So we write it as 1 minus eta is equal to T2 upon T1. This T2 by T1 can be represented as 1 minus eta. And 1 minus T2 by T1 is equal to eta. So we substitute that here. Then the equation becomes beta is equal to 1 minus eta by eta. This is the relation between beta and eta. That is the relation of efficiency and coefficient of performance of refrigerator. The same method is followed in the case of heat pumps as well. The only thing is heat is given into the room. That's all. Let us consider a few facts here in order to understand the significance of this. From this equation, we understand that beta actually stands for efficiency. That is, coefficient of performance of the refrigerator stands for the efficiency. Now, the second point, look at this equation. Beta is equal to T1 divided by T1 minus T2. From this equation, it is clear that less the difference between T1 and T2, that is the temperature of the source and the sink, respectively, greater the coefficient of performance beta. Greater the coefficient of performance beta, greater the efficiency eta. That is, less the difference between the temperature T1 of the environment and T2 of the foodstuff that is kept inside the refrigerator, the more the efficiency, that is, more the cooling. As the refrigerator continues to work, what happens? T2 goes on decreasing because more and more heat is absorbed from the inside of the refrigerator. Ice will be formed inside the refrigerator. T1, the temperature of the external environment will be constant. Delta T increases and the efficiency of the refrigerator decreases. That is, the ability to cool decreases. In order to avoid this, the refrigerator should be periodically defrosted. This is a very important point. Questions are asked from this point. You may be asked to give reason why refrigerators should be periodically defrosted. It is to improve the efficiency of the refrigerator. I hope it is clear. Now look at the equation. Beta is equal to Q2 by W. From this equation, we understand that a certain amount of work has to be done on the working substance in order to get the cooling effect. So Q2 upon W cannot be infinity. But from this equation, beta is equal to T2 by T1 minus T2. T2 is a bigger quantity and T1 minus T2 is a smaller quantity. So beta will be definitely more than 1. That is greater than 100%, not infinity. Because W is not equal to 0. You can note a difference from heat engine, not heat pump, heat engine. In the case of heat engine, efficiency is less than 1. It is not 100%. I will just note down these points here. I have given all the points here for you to refer. Coefficient of performance beta of the refrigerator represents the efficiency of the unit. Smaller the delta T, that is T1 minus T2. That is the difference in the temperature of the surrounding and that of the foodstuff inside the unit. Greater the value of the coefficient of performance. That is greater the efficiency. T2 goes on decreasing due to formation of ice inside the unit. But T1 remains constant. Then T1 minus T2 increases and coefficient of performance beta is reduced. So it is essential to defrost the refrigerator. Then T2 increases. T1 minus T2 decrease. Then the coefficient of performance beta also increases. Work has to be done for the working of the refrigerator. So W is not equal to 0. Coefficient of performance beta is equal to Q2 by W and it cannot be infinity but is always greater than 1. I hope this video was of great use to you. If you think it is useful, do like the video, share the video with your friends and also leave your feedbacks as comments in the comment box below. If you have not yet subscribed my channel, do subscribe it now and also press the bell button and all buttons so that you get intimated as soon as new videos are posted. Thank you very much for your support. We will meet in the next video with the next important topic, that is second law of thermodynamics. Till then, bye. Take care.